Okay, students, in this lecture, we will discuss about the type of motion. Two different type of motions there. One is uniform motion. Another one is non-uniform motion. Uniform motion. When a body covers equal distance and equal time interval, the body is said to be moving at a uniform motion. When a body covers unequal distance and equal time interval or equal distance in unequal time interval, the body is said to be moving with non-uniform motion. Now, students, what is uniform motion? Let's take the example. Suppose I have a car moving from point A to B, let's say. Now the car covers the distance of 5 km in 1 hour. Next 5 km in 1 hour. Next 5 km in another 1 hour. And next 5 km in 1 hour. Students, you can see the car is covering a distance of 5 km every 1 hour. So it means the body is covering equal distance in equal time. 5 km, 5 km, 5 km, 1 hour, 1 hour, 1 hour. So equal distance in equal time interval. If the body moves like this, the body is said to be moving uniformly, or the body is said to be in uniform motion. Now here you see, when a body covers unequal distance and equal time interval, unequal distance in equal time interval, or equal distance in unequal time interval. Let's take the example. Suppose the body covers 5 km, 5 km, 5 km, 5 km. Now the body is covering same distance. But let's say this is covered in 1 hour, this is covered in 2 hours, this is covered in half an hour, and this is covered in, suppose, 3 hours. The body is covering equal distance, but in unequal time. So the body is moving non-uniformly. The body is in non-uniform motion. Say suppose the body is covering 5 km, 10 km, 15 km, and say suppose 7 km. Now this time the body is taking 1 hour, 1 hour, 1 hour, 1 hour. So 5 km, first 5 kilometers covered in 1 hour. Next 10 kilometers covered in 1 hour. Next 15 kilometers covered in 1 hour. 7 kilometers covered in 1 hour. So this time the body is covering unequal distance but in equal time. So if the body moves this way, the body is said to be in non-uniform motion. The body is said to be moving non-uniformly. So students, I hope you understood what is uniform motion, non-uniform motion. Here is an example. A car moving 2 km in 2 minutes, 2 km in another 2 minutes, and 2 km in next 2 minutes, and so on. The body is said to be moving non-uniformly. Now, here is an example of a non-uniform motion. A car moving in a crowded street. Students, imagine a car moving in a crowded street. The car will not cover equal distance in equal time. If the street is crowded, the movement of the car will be slow. And if it is not crowded, the movement of car will be fast. So the car will not cover equal distance in equal time. So in that case, the car is said to be moving non-uniformly. Students, a body in uniform motion moves with a constant speed. If the body is moving uniformly, the speed of the body remains constant. The speed will not change. Throughout the motion, the speed of the body will remain the same. That's the nature of a uniform motion. But suppose if a body is in non-uniform motion, the body moves with non-uniform speed. Body moves with non-uniform speed. It means the body moves with different speeds. Sometimes the speed may be fast and sometimes the speed may be slow. So such type of motion is also said to be accelerated motion. Now let's understand, student, what is acceleration? This is a physical quantity. Like we discussed distance, displacement, speed, velocity. These all are the physical quantities, measurable quantities. So we have another physical quantity called acceleration. Now the word acceleration is very familiar to us. Suppose if you are driving a car, if we want to increase the speed of a car, we press the accelerator and the car starts moving faster. That means the car's speed increases. Car's speed increases. So if I want to slow down the car, we press the brake and the car slow down. So in both the cases, the car is in acceleration. We say the car is in acceleration. More precisely, we say if the car's speed is increasing, if the speed of the car is increasing, we say the car is under acceleration. If the speed of the car is decreasing, we say the car is in deceleration or under deceleration. So how do we define acceleration? Technically, this is how we define the acceleration. So rate of change of velocity is called acceleration. Students, you know what is velocity means. Velocity is the speed of a body moving in a particular direction. So rate of change of velocity means at what rate the velocity of a body is changing. Means every second how fast or how slow the body is moving and in what direction. So that's what the velocity changing. So rate of change of velocity is called acceleration. Students, velocity is a vector quantity. So velocity has both magnitude and direction. So when I say velocity changing, it means any one of the two. If it changes, if the magnitude changes, direction remaining constant, we say velocity is changing. If the direction is changing, magnitude is constant, even in that case, we say velocity is changing. If both magnitude direction changes, we say velocity is changing. So for the velocity to change, any one of these two, either the magnitude or the direction, must change. So if any one of these two, magnitude or direction is changing, velocity is changing. And if the velocity is changing, the body is said to be under acceleration. So it's not necessary for the body to have acceleration. The magnitude is not changing. Students, one more time. If the car's speed is not changing, if the car's speed is constant, even in that case, the body may accelerate if the body's direction is changing, because change in direction means velocity is changing, and velocity changing means acceleration. The body is accelerating. So the body's speed or the car's speed may change without changing direction. So in that case also the velocity will change. So changing velocity means the body is under acceleration. So the body to have acceleration, the body's velocity must change. Now for the body's velocity to change, so any one of the two, either the magnitude or the direction. If any one of those two is changing, the velocity is changing, and velocity is changing means body is accelerating. So mathematically, how do we define acceleration? Acceleration is the ratio of change in velocity divided by time taken. Ratio of change in velocity divided by time taken. Say suppose I have an example. Let's say initially a car, at this point the velocity of the car is 5 meters per second. And after some time, let's say suppose the car is at this point and the speed has changed to 15 meters per second. Because the body's speed or the car's speed has changed, that means the car is in acceleration. Let's say for this speed to change, how much time is taken? 5 seconds. That means the car's speed has changed from 5 to 15 in 5 seconds. So how much is the acceleration? So according to this definition, change in velocity, how much is the change in velocity? Say 15 minus 5, that's the change. So change of 10 took 5 seconds. So it's 10 divided by 5 means acceleration will be 2. So this is how we calculate change in velocity. Final velocity minus initial velocity will give us the change in velocity. And for this change to take place, how much time is taken? The time will be written here. If I simplify this ratio, I'll get the acceleration. So students, acceleration is a physical quantity. How do we measure them? To measure acceleration, we have a SI unit called meter per second square, which can be written like this, ms minus 2. So acceleration SI unit is meter per second square. Now student, let's understand what is the meaning of acceleration 1 meter per second square. If I say suppose the body is moving with acceleration of 1 meter per second square, what does it mean? It means every second the body's speed is changing 1 meter per second. Let's understand this with the help of this example. Suppose, say student, initially the body is at rest, the car is at rest. Let's take the car or any moving body. Initially the body is at rest. Now after some time, let's say the speed becomes 10 km per hour. Next 20 km per hour, 30 km per hour, 50 km, 40 km per hour and 50 km per hour. You can see in this example, the car's speed is increasing, or the body's speed is increasing. That means the body is under acceleration. Initially, when the speed was 0, let's say the time is 9 a.m. Now after 1 hour, when the time is 10 a.m., the speed has changed to 10. Speed has increased to 10. At 11, the speed has increased 20. At 12 noon, the speed has increased to 30. And at 1 p.m., the speed has increased to 40. And at 2 p.m., the speed has increased to 50. So speed has increased. That means the body or the car is in acceleration. how much is the acceleration? Now, when I ask how much is the acceleration, what I'm asking every hour, how did the speed of the body changed? So you can see, student, every hour the speed changed 10 kilometer per hour. 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 Speed is changing, but every hour the speed is changing at the rate of 10 kilometer per hour. So here is the acceleration. So we have an acceleration of 10 kilometer per hour every hour. So 10 kilometer per hour every hour. 10 kilometer per hour every hour. 10 kilometer per hour per hour. So in short, we write like this: 10 kilometer per hour square. So this is the acceleration. Now student, when I say acceleration 1 meter per second square, it means the body's speed is changing every second 1 meter per second. Every second the body's speed is changing, increasing 1 meter per second, 1 meter per second, 1 meter per second. That's what we mean by the acceleration of a body as a 1 meter per second square. Student, the speed of a body may change uniformly, may change non-uniformly. Now in this example, the body's speed has changed uniformly. Means every hour the speed is changing constant. 10, 10, 10. But in our daily life, the speed may not change this way. We may increase the speed, we may decrease the speed. So our speed may not remain constant. So in that case, the body is said to accelerate non-uniformly. So here is an example of a body undergoing uniform accelerations. Uniform acceleration means when the body's speed is changing, body speed may change, body speed may increase, or the body speed may decrease. If it increases or decreases uniformly, means equally, in equal time, we say the body is under uniform acceleration. Students, throughout this chapter, we'll be discussing about the uniform acceleration, the body under uniform acceleration, or the motion of a body under uniform acceleration.